Well, welcome. Before we get started, I always ask to remind you of a couple of things. Please make sure your cell phones are on mute. And also, you've been provided with these forms to fill out at the end of the presentation, so please do that. My name is Jules Urbach. Just to tell you a little bit about myself, my history is pretty much tied with 3D games on the web. Back in 1996, I started working on 3D web games for Shockwave. And I don't know if many of you know or have seen Real Pool, which was a 3D game that was launched on Shockwave. I think it was one of the very first games to be launched inside of a web browser. Just before we get started, I'd like to sort of get a show of hands just to know, sort of how you guys sort of break apart in terms of what you've used, what technologies you're familiar with. How many people out there know of Flash or develop with Flash? Excellent. How about Director? Okay. How many of you have developed a 3D game for browsers or for online? Interesting. Okay. Well, that gives me an idea of sort of the audience, which is a good way to start. Back in 1996, when I first began thinking about how to get 3D games in a web browser, web pages were pretty simple. You had 2D images, formatted text, and not much else. And today we see web browsers that are able to host pretty sophisticated applications like word processors and calendars that are done in Ajax. But despite all of these advances, it's still challenging to get a 3D game inside of a browser, in some ways more so than when we started back doing Real Pool. For example, some of the challenges that we face now with a modern game inside of a web page have to deal with download sizes. For example, our games nowadays use normal maps, HDR maps, occlusion maps. They go beyond simple texture maps, and they don't necessarily compress very well with traditional methods. So that's sort of the first challenge that we've faced moving from the Real Pool days to what we're doing now, which are much closer to what you see on a console. We also sort of had to face the emergence of browsers on non-desktop PCs. This includes cell phones, it includes set-top boxes, it includes console systems even. And so, when we started out, it was pretty straightforward to launch a game on the web. It was going to be on a PC. The browsers were just either Netscape or Internet Explorer. And now that's changed drastically. You have web pages running on a PSP, so there's just a lot more effort that needs to go into designing 3D web games that are going to run across all these platforms. Now, just back to the PC, that even there's a lot of things that have changed. For us, we rely on having a plugin that runs inside of the web browser, and there's now a lot of user wariness for that because there's a lot of spyware, unfortunately, and adware that gets installed through ActiveX controls. So you see, changes in IE that affect even how Flash and Shockwave play, but they affect us as well. And anybody that wants to put out a piece of technology that has to install after, on top of the browser has to sort of deal with those issues. And then, of course, there is the impending impact of Windows Vista and IPTV and these other technologies, which are going to have probably vast implications for what the web browser is. And this is, again, something that will span not just desktop PCs, but also other devices as well. Now, the first question I want to sort of pose is, why is 3D in the browser still a second-class citizen? And by second-class citizen, I mean compared to Flash. And in my opinion, this is twofold. Firstly, compared to Flash, no 3D web browser plugin has 98% penetration. And that's something that for the web I think is very important. You want to have ubiquity whenever possible. People expect content to be able to run instantly and quickly. And that leads to point number 2, which is that a lot of 3D content out there is not light. The file sizes are pretty big, larger than 10 megabytes on the average. And granted, these are a lot of these sort of fall in the category of demos that are put out for larger games, some of which are actually in the hundreds of megabytes. But the truth is that if you're going to talk about having a 3D game run inside of a web browser, you really need to sort of try to match what Flash does, which is this integrated, simple, embedded experience without any load times or waiting times. So for us, in our experience doing web games, there are really 4 things that we really want to try to do. One is, as I said, content should work ubiquitously, and it needs to be delivered seamlessly. Casual users just expect it to be transparent and quickly loaded, and if it's not, a lot of people just can click away. They haven't really made a large investment into your game project or content, and so the back button is just a few inches away. Another aspect is that content really needs to be cross-platform, and it needs to be designed that way I think from the beginning, if you want your content to be evergreen, in other words, we've got a large library of games that we developed really just for the PC and the Mac, and now we're looking at putting these onto other systems and other devices. And so we're, part of the reason why we invest so much in our technology is to make sure that we have these avenues available to us always, because the web, as I said, is just going way beyond what we originally saw on the desktop, 7, 8 years ago. And finally, and this is really just more of an optional requirement for us, content should be easy to author, and the assets should be very easy to change and edit, even at runtime. And this is something that applies much more in a Web 2.0 world than it did when we were just doing simple 3D games. One of the things that we're looking to do is to have users and community sites built around content that is changeable in our games. And so one of the things that we're doing to address that, for example, is that the authoring tool now is for OTOY is built into the WebTime and web player. Going back a number of years, let's look at how we developed games at the very beginning. Now, Whirlpool was launched in 1999, but it was actually developed in 96, so it's been about 10 years since we started that. And looking at the specs, the game was 125K, which was nothing, even on a 56K modem. Modems, dial-up users, there's still a fairly large audience out there, so it's not something you want to ignore. We can develop very good games that run in hundreds of K. We were able to get 30 frames a second on a Pentium 90 with just 32 megs of RAM. And we ran on every system. And this was because we launched with a software renderer that allowed the game, and Flash is a software renderer as well. Director, before they added Shockwave 3D, was a software renderer. That means that you essentially don't have to worry about the hardware specs or how much video memory is on there. And back in the day, there really was nothing that even was viable for launching a game like this online. There's still some lessons from that we use today, which we'll talk about as well in a little bit. Finally, the plugin that we used to render the 3D was injected transparently, which I still think is a critical piece of technology that you need today to launch a game online. And the way we did it at the time was by turning our 3D engine, which was about a few hundred K, into a Shockwave Extra. And Shockwave at the time was pretty ubiquitous. It was installed on almost every web browser out there, so we were able to add our technology just one click on top of our game, and that worked really well for us. So Whirlpool was a huge success, and we're on game number 65 now, I think. So it's been we've done a lot of work since then. So let's take a look at what we are doing today. Now today, the OTOY plugin is no longer dependent on Shockwave, and there's a couple of reasons for that. We found one of the limits with Shockwave was that the lingo, which is the script language in Director, was pretty slow, and we needed our own solution to enhance that and make the games run faster. We also were concerned, even back then, when we started our own engine, which was in 2001, that was separate from Shockwave, that there was going to be an emerging market for web games on devices that Shockwave would not be ported to. And sure enough, that's been the case. I think Shockwave's been only ported once to the 3DO, if I'm not mistaken, and it hasn't really been anything since then. So we really felt that we needed to make sure we had our own completely independent solution. And so today we have there are about 70 million plus downloads of our engine, and this is the numbers we had in 2003, so it could be more now. The whole OTOY engine, the current version, is 800K, which is still smaller than Flash. And now we have many step mechanisms, not just the Shockwave Extra, which is what we started with, but many more that install the web plugin depending on what the user may have. And that includes an ActiveX control, a Netscape plugin, we have direct OLE installation, QuickTime codecs, and as a fallback solution, we even have a tiny 100K executable that can be downloaded with a link and then installs the engine as well. So these are sort of the things that we've added since we started with the Shockwave Extra. And this is what our games look like today. They're obviously much higher quality and much higher polygon count than Whirlpool when we started with that. Now, basically, as far as content goes, I described a little bit about how the technology behind OTOY is currently set up, but the content actually hasn't changed drastically from when we were doing Whirlpool. And starting with the file sizes, look at dial-up speeds. They were 5K a second at best on a 56K modem. On a DSL line, that's the average DSL line is 30K a second. In my hotel room last night, it's 15K a second. So you're talking between 3 to 6 times faster, even on many broadband speed connections. And broadband for cell phones, things like that, they're not the same as a T1 line or a high-end cable line. And even if something is 6 to 8 times better than what we started with dial-up speed games, we still want to keep games under a megabyte. So that is something that we still stick to. Even games designed for broadband, we try to make sure that at the very least, every level is under a meg, and I think that served us pretty well. The heap file size is very small. What we've developed since sort of moving from Shockwave has been a lot of proprietary codecs. Some of them include image compression that's about 5 times better than JPEG, 1.5 times better than JPEG 2000. Going back to some of the challenges I posed in the first slide, we developed compression specifically for normal maps, for HDR maps. Some of these things we haven't even really seen anywhere else because it's for high-end 3D games, and yet for the most part, console developers have a DVD to put it on. Obviously, it's changing a little bit as you look at solutions like Xbox Live Arcade, where you're streaming in content. So, it's interesting. I think that some of the things we're developing might actually have a very good application there. Now, the software renderer is still used significantly for a lot of our projects. And the reason why that is that you have a huge number of machines out there that are DirectX 7 or lower, and in fact, we just had a project that was spec'd out with, for a computer with 8 megs of VRAM, and so for that, the software renderer is actually just as good as the hardware solution. We're also dealing with the reality that there's a lot of people out there with embedded graphics chips, namely the Intel graphics chips are very widespread. And this is again, our audience isn't hardcore gamers; it's casual gamers that are on a web page, and a lot of laptops have integrated graphics chips that just don't have. Even if they're new, they just don't have the performance and capabilities of the equivalent desktop chips, from even 4 years ago, made by NVIDIA and ATI. An example of this actually is the Intel chip that just came out, and it's used in the Mac Mini, brand new computer. And it does have Pixel Shader 2.0, which is pretty high-end graphics, but it doesn't have very good speed. So for that instance, for example, for those chips, what we've done is that we use the software renderer to render the scene offline in software, and then we send it to the graphics card to actually do something called deferred shading. And then that enables us to gain the benefit of that particular chip and utilize the software renderer. On earlier chips, we pretty much find that the software renderer is actually better. There is, of course, a huge number of people now with hardware cards. And so what we found with developing content is that we have to address both of these things. We have to deal with hardware cards that, on machines that have DirectX 9 or 8 or better chips. And we also have to address this vast audience of people that either have embedded chips or older machines. And so that's been a challenge for us that we've been dealing with in the last year. And you'll see some of the solutions that we've come up with to deal with that. We also have our own scripting language, which is something we developed when we left using Shockwave. And the scripting language is pretty broad. It's similar to C in that you can have it's high performance. You can have typed variables, pointers, all that stuff. But it's also very similar to Lingo because a lot of our developers that use our technology come from Flash and Director. And there are also, of course, a lot of coders that come from C and the C++ world. So we try to accommodate both through a scripting language that is actually pretty easy to use. And because we control both the scripting parser and the virtual machine in OTOY, we're also able to add features that are pretty unique. For example, we can have the GPU, the graphics card, actually compile certain portions of script so that the graphics cards can actually be programmed from the regular scripting language with the same syntax that you use to program our games. And the syntax is actually pretty simple. So we found that shader development in OTOY is pretty easy. And you'll see some of the examples of that a little bit later as well. Now, the other big aspect that we sort of were pushing on in the last year, beyond just doing 3D games, was chat and multiplayer and social networking, which are, of course, now huge aspects of online content. And it was something that when I first started this, there was a New York Times article that came out about it in 2004. It was really, the Web 2.0 world hadn't exploded yet. And so I was trying to sort of get in on that very early. And we built in all sorts of features into OTOY that allowed you, for example, to connect to IM. So we support all the major IM clients, AOL, ICQ, MSN. We had multiplayer that was built into the client. We added features for sharing files and even hosting applications. A lot of stuff that we felt would be very good for community and social tools. Essentially, all these could have been built to use into a chat engine or a chat client in OTOY, which could have been part of our games, and that was the intent. We also, through the networking code that we did, or the networking work we did, we created a lot of other interesting opportunities. For example, we found that we could even create grid applications by using the peer-to-peer network that OTOY could host to actually run applications over a series of machines. And we also added just some simple features that were originally pretty tricky to get to work in Internet Explorer, which limits how you can drag and drop objects. But we're able to figure that out, and we have drag and drop support for textures, shapes, and even document files, so that if you were to create, let's say, a MySpace type application in OTOY, well, not only can you post pictures and have that really be easily created on a web page, but you can also natively have PowerPoint and Word documents and all sorts of other formats that we ended up supporting. And all of these actually run in 3D on the surfaces in the 3D renderer. So this is an example of some of the features running in OTOY. Firstly, objects are no longer limited to the browser pane. So we have objects that actually can fly out of the screen, run on the desktop. Secondly, as I was mentioning before, we have full integration with with other aspects of the desktop. So we can run, for example, and this is showing the Nickelodeon webpage running live on the ship, running outside the desktop. Just one quick application you can do with something like this is you can actually have a custom web client that's built in 3D that loads actually from within the web, since all of our technology is installed through the web page. And so this is something that we were looking at doing for having customized web frames specifically for one site. But of course, you can also use this technology to have ads and entire websites just rendering inside of 3D space. And that was one of the reasons why we pursued it. This works not just with Flash and HTML, but also with director content. It also works with even full executables, which is one of the key pieces of technology we added. We can actually host binary runtimes that are signed by us inside of OTOY, inside this space. So these are this is sort of a summary of the features that we were adding in that area. In other words, embedding web pages, Flash and director content onto surfaces. One of the applications of actually having objects be able to run or move outside of the desktop pane is that you can actually have two different portals that are in, let's say, two different web pages, and actually have objects traverse between the two of those. And that was one of the reasons why we designed the system to actually not just have objects pop out of the browser frame, but there's actually a pretty complex system that changes the transform of the object so that if it's in one space, in one world, it actually gets scaled and moved as it shifts towards another portal that could host it. We also added full support for JavaScript and DOM right in the scripting language, so you can access Flash variables, JavaScript variables, the same way you would any sort of native variable in our scripting language. And as I mentioned earlier, the author tool is now built into the web player, so you can have people edit the content right as it's running inside of a web page. And tangentially to that, we also added digital signing, so that you can sign and lock your content and pretty much decide how you want others to be able to change it. And that system is something that is pretty much deployed sort of on a per project basis, but those tools are there for that purpose. And that's something that, going back to what we want to do with wicked-fiable 3D web content, the digital signing tools are actually very useful for that. And then finally, we have a pretty cool feature, which is going to be hard to show because you need a cell phone for it, but it essentially allows our content to be translated into HTML. Or if there's something better available on a client machine, it can translate into that as well. And this sort of comes back to our controlling how the parser and virtual machine work. We're actually able to, on the fly, not just at author time, but on the fly, translate something either by hosting it on a server node in the peer-to-peer network that OTOY could be running, or just through some other conversion tool that's local to the client, translate an application, even with 3D, into a stream that'll run on a cell phone or a set-top box, essentially a client without the OTOY binary runtime being installed. And this is very critical for our trying to reach clients that just don't have our engine installed, especially because we're limited by, even when we want to port our application to other devices, it's not necessarily possible. We don't have the tools necessarily or even the resources. So this is one way that we were dealing with getting at least simpler content onto cell phones. And it worked perfectly for our chat applications. And for the 3D games, what we found was that it really worked great for turn-based content because essentially the game would be rendered by one of the nodes in the OTOY servers and then streamed into the phone, but the speeds weren't great. What we're trying to do to address that is we're actually looking on cell phones and devices that support Java 3D. We have one of our developers actually wrote a very good Java 3D engine, so we're looking at supporting all the way up until you have a native binary solution, some form of playback of OTOY on any device, any system. Now, there should be a white paper that maybe either you received or that you can link to from OTOY.com. It describes in a little bit more detail how this process works, and you're certainly free to look at that and email me any questions, or we can talk about this after the lecture is over. I will take a sort of moment to actually step away from our technology and look at a lot of the other things that are out there, because there are some very good tools. Now, some of these don't exist yet, and that's actually the first one on the list falls into that category. 3D and Flash is really something that isn't there yet. It's something I think a lot of people would be interested in seeing. And I don't know whether it's going to happen, whether it's going to be in Flash 9, whether it's going to be in Apollo, which is the code name for Adobe's desktop version of Flash. Could be. I think it would be very interesting. Certainly, if that does happen, you're looking at probably everybody out there having to get a new version of Flash. But then again, if you look at the very fast conversion rates for Flash 8, that would happen very quickly. So I think this is something that everybody should be keeping their eye on. As far as sort of looking at other potential Web 3D standards, X3D could happen. I think that the X3D shows a lot of promise for one reason in particular. It supports shaders, which I think if you don't do that, it's going to be, I wouldn't find it very useful. So they do have that support in there. But the problem with X3D is similar to, I think, what people are facing with SVG or even Canvas, both of which are sort of these open standards that frankly haven't made any dent in Flash. And I think that it's, just having an open standard isn't enough. I mean, I think it's just the practical reality that you need to be installed on a lot of machines to really make sure that, whatever content you're making is going to run everywhere. I think that, it could go somewhere cool, but if you look at VRML, VRML didn't work because it wasn't implemented well by a lot of the players out there. So I think that X3D is going to, it's just, you have to sort of wait and see where it's going to go. But I think that some of the players that have come out so far have actually been pretty good. So, this shows some promise. Shockwave 3D. Now, this is a tool that we have a lot of familiarity with since we were based on Shockwave in the first place. And I think that, frankly, for deploying web content out there that you want to run on a Mac and a PC, and you don't necessarily need to run it on all the machines out there. You don't need to have the highest end graphics. Shockwave 3D is great. It's fairly inexpensive to buy. It's pretty ubiquitous. However, we've seen that it is obviously showing its age. It has DirectX 7 rendering, which is not necessarily the latest and greatest, especially compared to some of the other ones that are on this list, which we'll get into. And frankly, the reasons why we abandoned Shockwave are still applicable today. I think Lingo is slow. I think that I don't know if Shockwave is going to be ported to a lot of the platforms we really want to make sure we're going to support. Now, if you want to do high-end Web 3D content, I think Wild Tangent, Unity 3D, and Virtuals are all great technologies. I think that Unity 3D, which is OpenGL, actually looks great. I think Virtuals looks excellent. I think Wild Tangent, if you're looking for doing things other than the PC, I don't think it works other than on PCs. But certainly for those kinds of, if your focus is just putting out a desktop-based web, for PC-based Web 3D game, these are all good tools. My concerns with them really are just the footprint, the portability, dependency on the OS, same as what I have for Shockwave. I would definitely have to mention Java 3D because I think that cell phones that have J2ME installed, for example, there's this tantalizing way that we see of putting out, so let's talk about this Java software render. There seems to be a way to sort of get stuff going on these older devices through Java. There is, of course, a separate version of Java that actually connects to the hardware cards. And I'm not very familiar with that, honestly, but I think that they're probably, if that's the approach you're taking, they're probably more interesting solutions than just using Java for that. So I think that Java 3D has potential for cell phones and embedded devices. It's also very interesting that Java 3D, or Java itself, could potentially be on the next iteration of DVD players. So, I mean, that's one of the reasons why I think it's worth looking at. The 800-pound gorilla on this list is Windows Vista. And there's no doubt about it, Windows Vista is going to radically transform how 3D works on the desktop and in the browser. I think that the Windows graphics foundation that they're building this on is going to change a lot of things. There's just no doubt about that. So what I have my doubts about are the following. I think that portability is an issue. Now we've seen Windows graphics foundation actually run in Safari on a Mac. So that's been demoed. I mean, Microsoft has demoed that. So there is this push to make it cross-platform. That's very exciting. But then, the demo didn't have anything running in 3D because they didn't have the 3D portions of it ported. So, again, it's a wait-and-see sort of attitude that I'm taking with that. I think there's no doubt about Vista potentially altering how cell phones that use the Microsoft operating system work. Potentially, if you believe all the things that are being said about XNA, it's going to enable, one solution for cell phones, for PCs, and potentially even the Xbox. But I think that those are, again, very Microsoft-centric technologies. I also, have to say that when we looked at the last sort of big change that Microsoft pushed, which is .NET, it's a cautionary tale because there's not a lot of people out there. I mean, certainly probably a good chunk of them, people out there don't have the .NET runtime installed, and now developers are even dealing with moving to .NET 2.0, which requires a whole other installation. And this is not a trivial download if you don't have it. It's 23 megabytes. I think 80 megs if you need more components. But regardless of that, I think the Windows Graphics Foundation technology is going to run into the same issues. You're going to have to wait a while for it to be downloaded everywhere. So I think that it's certainly not a question of if it's going to make a huge impact on everything that we'd be doing. But certainly the when is something that is yet to be seen. Now I'm going to sort of take a step back to OTOY and give you guys a postmortem of our games from last year. We released 5 games between 2004 and 2005. We released SpongeBob SquarePants, and Bleep 2 on Nick. We released Penguin Racers and a Menace last summer for Shockwave, and JetX Racing for Disney. And this is what went right with the 5 games. Firstly, All the games ran great in the software renderer. With software, 100% playback on every machine. There's really, we saw no sacrifice in terms of the speed. I mean, the software renderer is incredibly fast. So there was nothing we really had to worry about in terms of the speed or the gameplay, and yet we had total ubiquity. So the software renderer worked great in that respect for us. The games were small. Everything was, if the games were over a megabyte, well, then the first level was, under a meg. And the plugin installation is pretty much a non-issue for us these days. I mean, even though there are issues with people, worrying about ActiveX controls and stuff, we already downloaded in about 70 million people's machines. And the last version of the engine is not even 800K; it's 450K. So 800K is for this newer version that has all the hardware rendering and other features in there. And also, authoring is, our content for our developers at this point is pretty quick. The game development time, 2 to 3 months for a completely new game. And, we're seeing developers reuse components from prior projects, and this is just bringing down game development time significantly and costs as well. Now, here's what didn't go so well, and this list is essentially our to-do list for OTOY 2.0. Well, back to the software renderer. The 16-bit software renderer really is showing its age. Not so much because it's not fast or that it doesn't work everywhere, but really there are just a lot more people out there, even just in the last 2 years, that have DirectX 8 and DirectX 9 quality graphics cards, and we can't ignore that anymore. And as I was mentioning earlier, it's sort of created this sort of dichotomy. We have to sort of address both. We can't abandon the software renderer. We want to make sure that works for those half of the people out there or more that don't have good cards, but we need to make sure that we found a lot of clients that were sort of griping about not having hardware support, so we had to deal with it. Chat and multiplayer solutions were just too expensive and complex for a lot of our smaller clients. Same thing with buddy list integration with the major gateways. We only had one client that was able to actually work out a deal with AOL for that. And so for a lot of, so we really had to sort of rework how we were dealing with instant messaging and chat inside of our games, because it wasn't, I think for a lot of clients, putting out a game on an HTTP server and putting a few files out there is nothing. But when you're dealing with hosting servers that can go down and all the the scalability issues of especially scalability issues of how many players you're going to get, those are all issues that really scared a lot of our clients. And so we ended up selling them games, but not a full solution that included chat and multiplayer. With file and application sharing, it honestly was just something that we couldn't release to enough developers because of security issues. We didn't want people building spyware, adware, absolutely not in this. So, the security issues for that were really something we needed to think a lot more carefully about before either deploying content or development tools that could use that. And also, we had problems with our OS X client in Safari, so we had to sort of deal with these issues. And while none of these were, this is not a huge list, it was, each one of these things really took a lot of thought and effort as we were working towards building OTOY 2.0, which is now in beta testing and is being released this summer for our next round of games. So with OTOY 2.0, the first thing that we did was we needed a brand new 3D engine. And this is, this flyover is a rendering from that. We also moved, I'll be showing you guys more examples of the rendering as well. It's pretty good. We also moved everything to peer-to-peer for chat and multiplayer and instant messaging. Now, granted, when we did that, you lose AOL and IM, but one of the things that it did for at least for multiplayer is that you really then it simplified significantly the deployment of games, because you don't have to worry so much. I mean, you need one server maybe for tracking purposes, but there wasn't necessarily as much of an investment on the client's end for hosting massive servers, and scalability issues were just generally gone. And then we focused a lot more on the browser busting features, the things that were related to popping things out of the window and and Flash and directory integration. For example, I mean, now one of the things we couldn't do earlier is Flash could render transparently on a 3D surface inside of a hardware card, and that was a tricky thing that we figured out. So a lot of those things were really just dealing with taking some of the earlier features that we had and moving them to the hardware renderer. And we're also working on new ports as well, which I will talk about in a little bit. So looking at the 3D engine, this is really our big shift for OTOY 2.0. Our goal was really threefold. One is we wanted to make sure the software renderer was as good as it possibly could be. So firstly, we just changed it to 32-bit render, and then we added 128-bit rendering, which is what that fly was rendered with. HDR rendering, if you guys aren't familiar with it, is where you have high dynamic range. It allows you to do Pixar quality rendering, basically. And basically, we also added support for normal maps, cubic maps, spherical harmonics. These are pretty high-end rendering features, but these work in the software renderer now. And the software render speed wasn't affected by them. So we're still getting the same speed that we were getting before when we were just rendering 16-bit. The software renderer is essentially about the same speed as DirectX 8 hardware when it's running at 640 by 480. So we covered the low end as best as we possibly could with these upgrades. In the mid-range, we worked on DirectX 8 and OpenGL, which we added to the engine. And this was really a difficult step for us because if you look at, and certainly if you look at software renders that are out there, for example, and the two that I know of offhand are Pixomatic and Swift Shader, both of which give you very good performance. But our games actually, when you can actually try these out with our engine because they actually work as DirectX 9 plugins or DirectX plugins, and our games run really slowly. And the reason for that is not that the renderers are slow, but the entire architecture for how we do and render a software game is completely different than than Direct3D or hardware-based content. It's completely different. So we had to really work on a whole new architecture that enabled one authored game to run in both software and hardware without any compromises in both, and we did that. So this is a rendering of a scene in the DirectX 8 renderer, and it's essentially our content can be authored once and runs in software and hardware, and the software render fully the same speed. All the issues that you deal with in terms of being able to, let's say, access the vertices and the order in which they're done is mapped between hardware and software. So you really can do a lot of complex effects that don't necessarily depend on you running in one mode or the other. Now, Pixar quality rendering in a web browser. This is our real goal of going into 3D. If I'm going to sit there and rewrite the full 3D rendering engine in our technology, I wanted to get the best possible quality in a web page. And this is exciting stuff for us because if you look at the picture on the left, this is a frame grab from the movie, from Cars. And we're working, this is obviously a demo that we're working on for a Disney project. And it takes several hours to render, from what I understand. On the right is our engine, is OTOY 2.0, running in real time, 44 frames a second. And this is running in Shader Model 2. This runs on a 4-year-old DirectX 9 card. Not at 44 frames a second, probably more like 8. But obviously, what we did with DirectX 9 was we really just wanted to nail Pixar RenderMan quality shading inside of the engine. And that's, people have sort of come to look at us as a great solution for software rendering. We wanted to make sure that we had the equivalent on hardware. So our goal is we're going to cover both ends. We're going to get, if you build something in OTOY, it's going to run great in software, and it's going to just look amazing on a 4-year-old graphics card. And so we haven't even touched Shader Model 3 yet or DirectX 10 or any of these things. These are all renderings that are from just Shader Model 2. And even older DirectX 9 cards that don't have multiple render targets or floating point textures, none of these features are used for what you're seeing. So we really try to make sure that this standard that we're looking at, this is a skin shader, basically that all these things would just render as well as they could on the oldest possible hardware. And for us, that line is Shader Model 2. These are all just examples. Now this head is something that was made by one of our artists, so the size is actually pretty small. It compresses down to a few hundred K, but the shading is procedural, so you're able to get really good quality skin rendering. And our compression takes care of everything from the base textures to bump maps to normal maps and the HDR textures that generate the lighting. Another head model created by one of our artists. So to sort of sum up, the new features in the DirectX 9 renderer include displacement mapping, BRDF materials, which is what we used on the Pixar car, similar to what RenderMan uses. A lot of the stuff that we use for both the lighting and even compression is based on wavelets. We're working on moving more and more wavelet code into the GPU, the graphics, the shader stuff, so that we can do even better shadowing and lighting, and even compress some of these larger assets that are they need to be compressed in real time for lower-end machines. And we focus a lot of time on some of the hardest challenges in writing shaders, especially on low-end hardware that we're sort of targeting for the web, and that allowed us to do subsurface scattering for the skin and essentially unlimited lights and shadows with spherical harmonics. And the bottom line is all these effects work on the very lowest DirectX 9 cards from 2002 and newer. And even more exciting is that all these shaders that you've just seen are written in the scripting language, in OTOY. There's this exact same syntax that we've been using for the last 4 or 5 years to drive and move an object around. Well, you can sit there and use that to write shaders, and it's not as complex as writing things in FX or even HLSL. It's pretty simple, I think. Some of the skin shaders that, in fact, I actually had trouble sort of working on before I actually had the scripting language in OTOY ready to do that. It seems pretty simple to me. And sort of summing up again, there are these browser busting features that we worked on. Full support for HTML and Flash. Any DOM object and even Flash variables you can change in OTOY. Anything in JavaScript you can do in OTOY. And some of these shader features are pretty cool because we can now mix Flash and 3D content with shaders. And so you can have, let's say, a Flash movie act as a displacement map on a surface inside of OTOY. We improved drag and drop support so that it's secure. It was one of the reasons we didn't deploy it last year was that we didn't want people to be able to scan file names, and so when you drop something into OTOY, you just get the data back. You get an image back. You don't necessarily get the file name or its location. One exciting feature we added as well is embeddable executables, and this allows us to take any application, any binary application, let's say even a torque game that was done in some other tool, and we can actually host it inside of a web browser. Full compatibility just runs natively inside of a web page using, and it can even use our compression if the assets are exposed that way. And we also, again, worked on desktop objects, making sure that these ran in hardware at the best possible speed. We're working on a few upcoming ports for 10.4. Apple's been very helpful in sort of pushing us forward on that. And we want to see it work on. We want to see all our new shading stuff work on the Mac. And we haven't had a Windows CE port of the engine that we sort of had shelved for a while, and we're going to be looking at that again to see if we can get a native binary version of OTOY on the Windows smartphones. And then, obviously console systems like Xbox Live Arcade are very interesting applications for what we're trying to do with OTOY. So we're definitely looking at that more carefully for later this year. Sort of the broad picture of where all this is heading, I think for us, the goal of sort of sticking with our own technology is we want to maintain total abstraction. I mean, we really want to make sure that we have 60 games that we've done so far. We want to make sure we can bring those to any platform, that we're obviously able to sort of deal with very new features that just may emerge. Especially with graphics cards, I think it's just sort of been an amazing leap that we've made just from supporting just supporting DirectX 9. But really, what we're trying to make sure is that we have the ability to export to devices that don't have our plugin installed, and that includes using whatever it is we have on the device, whether it's Flash or Ajax or Java. In the very worst case, rendering a JPEG stream to HTML, and that's sort of a big focus for us. That's the technology. As far as what we're heading with with content, there are really two applications that we're working on internally with OTOY. And obviously, whenever we do something internally, we usually hope it leads to other developers and other clients wanting something similar. And that was exactly what happened with Ripple. It was an internal project that ended up going on Shockwave and ended up spawning 20 developers using it, using that as a basis for doing their own games. So, application number one, our idea for that is virtual worlds, and this is a screenshot of the virtual world that we're building in OTOY. This entire scene is about 1.5 meg. There's 200,000 homes with full interiors built in. If you guys are familiar with Second Life, I guess that's sort of what this is. Second Life inside of a browser. Again, that was using DirectX 8. This is using the DirectX 9 renderer with much better lighting. These are also just some other screen grabs, and I can show some of these running in real time for any of you guys that want to come up after the presentation is over. I can show some of these on the other machine I have here. So we spend a lot of time and effort actually on the assets, because this is something that developers don't have the ability to necessarily do. We've been working on these things since 2001. We've done about 6,000 buildings and objects and scenes, and they're going to be seeded to developers and put out through our system. And there's certain requirements that we have for how we're doing this that maybe are different than other people's virtual worlds. And this is just another scene in New York. So firstly, this is going to be 100% web-based. There's going to be nothing to download, nothing to install, zero. Just you go to the web page, you're in the world. There's going to be 100% integration with the OS. If you go back to all the features that I was talking about with being able to drag and drop objects and render documents inside of OTOY, well, this is where it comes in. Basically, you're going to be able to go into your room and put a poster of a Word document or a video stream on there. And, essentially, the links between, just as Microsoft sort of blurred the lines a little bit with having your folders and the web pages sort of be in the same type of, system, we're going to try to do the same thing with OTOY. And one of the things we can do now is obviously have things that render totally outside of the context that's, of the web page. So we can have things that are objects that are put inside of folders and so on and so forth. Another requirement that we're absolutely committed to meeting is that it's photorealistic, and certainly with this new rendering that we have now, we're able to do that. The enormous asset library is a must. I don't think the developers or clients are willing to commit to that the same way we are. And so we're looking essentially at just in terms of the model for this, it's going to probably just be advertising based. And so we're not going to have any sort of subscription model for it or payment model, because I think that's going to sort of stunt its growth. And again, going back to Second Life, the last time I checked, I think they had about 100,000 users, and maybe it's more now. But if you compare that to even just we put one game out on Shockwave, and the first week you're seeing 1.5 million people or 1.2 million people playing it. We want to see those numbers, and the volume for us is much more important than just collecting a subscription fee. So we're not going to do that for any of these virtual worlds. I think sponsorships is probably the way we're going to monetize it. And the other thing is we want to make sure that it's wikifiable, meaning that users are able to go in there and lock up their assets or lock up the things they contribute, open it up to others, and essentially Wikipedia is I love Wikipedia, and I think that that's something that can be applied to this kind of application. And as I mentioned at the beginning of this lecture, it's just tricky with 3D assets. I mean, everything from dealing with how do you edit, rigging on a model or shaders or material properties. I mean, these things are just not as simple as text in 2D, but we're dealing with it. And so this is sort of a longer-term application for us, but we've made pretty good progress. And those screenshots are actually from the actual application we've been building. Application number 2 that we're working on this year is sort of raises a certain number of eyebrows because it's essentially animated movies, linear content, but running in real time in OTOY. And certainly now that you've sort of seen a little bit of the rendering quality, just as we're starting to see even our engine sort of approach pretty close to what you're getting with the Pixar offline render, well, why don't we just stream down an animated movie in OTOY? And why sit there and turn it into a compressed video file when on at least half the machines out there with DirectX 900 or newer, we can render it in real time and completely forget about issues of compression or resolution. I mean, in fact, if you actually build an animated movie this way, well, then you never have to worry about reformatting it for 1080 or 640 by 480. It's just going to render in real time on whatever the system is, and that will cover things that are coming down. Maybe 5 years down the line, you'll have HDR displays or displays with with wider angles. All of that is covered by doing animated content this way. So that's very interesting to us. I mean, I think it's maybe a little bit on the curve there, but it's something we're looking at very carefully. And certainly, if we get a budget, let's say if you're doing an animated movie, well, 80% of that can go right towards making the game because we're building it in the same engine. And sort of where that leads is that we're going to end up having content that is essentially maybe centered around an animated movie or an animated show or even episodic content, but also is bundled with all the other things we've been doing up to this point, including video games and the community tools. In the same way that a DVD movie, obviously comes with extras that enhance the linear experience. And so, just some of the couple of projects we're doing next in this context. One of them is with a very talented artist named Alex Ross, who's a good friend of mine, and we're working on a promo for his new book, which is coming out next month. And this is one of the scenes from it. So we're working on a bat cave, 40 seconds short, but you're also going to be able to go around the bat cave and look at the different things, get the history of each object, and so forth. And then the other thing that we're working on is it may or may not be used for the Transformers movie, but we're working on a city block scene that's going to be both an animated piece and also an interactive thing as well. So I can even show you the animated portion of it, which is pretty cool. So this is all done in Max. And it's basically, unfortunately, after the time of the movie, it's not going to look anything like this, so we're going to have to redo the robot once I saw the real effects for it. But basically, I've been working with many different artists using many different tools, and these artists that I've been working with on this actually use Max. So this scene doesn't have any procedural textures in it. It should translate very easily to OTOY real time, and that's what we're going to focus on next. And based on our success with that Pixar car and the skin, I think that actually this is probably going to be one of the easier tests. But it's exciting stuff, and that's one of the things that we are really sort of hoping to do. Before I show any of the demos, I'd like to take some of your questions and address things that maybe I've sort of missed in the presentation so far. Are there any questions offhand about our technology, licensing, anything like that? Well, the license model for OTOY 2.0 is pretty straightforward. It's free, and the reason why, and it's free with one caveat, which is it has to run through our web player, and our web player just has a control panel. You can essentially launch commercial content. The limitations are you can't create offline content, but you can put something not just in our web page, but in any other web page you'd like. So it can be embedded in other people's sites. And generally, our larger clients would never agree to have a pop-up window or a control panel that allows essentially users to sort of change how the content works. But short of that, for independent developers, I mean, that's what it's designed for. We're not going to charge for that. So the tools that are going to be built into OTOY 2.0, there'll be a license that allows you to essentially create your own stuff and put it in your own page for free and commercialize it and put your own ads in there. However, the limitation is that there is going to be a flag that users will be able to mark the content as indecent. Potentially, that enables us to sort of see whether people are doing things that are not acceptable to the community at large, and we may need to remove content. But short of that, we imagine that it's a great solution for independent developers that want to be able to just pick up a tool and put out content using all of the technology you've seen here. So you can't really beat the price. There are still custom solutions that we're offering for our larger clients that include the web player without that, without the control panel in there, Some of the things that we do, for example, hosting executables, is not something we're just going to give out to every developer. We need to look at that at a case-by-case basis for security issues. But for the most part, I mean, all this is actually described on OTOY.com. The models for the free license and for custom solutions, all that is described in pretty much more detail than I can probably have time to go into here. So you can download that on OTOY.com if you want more information. Yes?
The player is a plugin for the browser, right?
I'm sorry?
The player is a plugin for the browser.
Yes, it is a plugin for the browser. He was asking if the player's a plugin for the browser, and the answer is yes. The content that we do is all for the web, and all those statistics I was giving you for this number of downloads is for the people that actually have installed our web plugin. So everything that you've seen runs inside of a web page.
So
Yes? Oh, I'm sorry. I'm sorry?
It's an isolated box like Flash. You said it supports DOM.
It does. Well, there's a couple of ways that we do that. I mean, one is if you're using DOM, for example, we have a layer that through ATL allows you to load OCX controls, and that is something that we are able to that enables us to obviously host things like Flash, things that host the web plugin. For example, that example that has the web page rendering on the enterprise. It uses ATL to render the HTML and Flash content on there. But inside the engine, built into the engine, is a full Comm interface, and that's something that there's nothing stopping us from putting that inside of a web plugin or even executable. And once we get a Comm pointer, we're then able to get access to any sort of Comm interface we want, and that'll run natively inside our scripting language. And so, for example, getting a Comm pointer to the instance of the web browser that's running enables us to change those properties. Now, obviously, that's not secure if we were just to leave it completely open, so we limit that. That's limited either to ourselves, and we expose a simpler API to end-user developers, or if somebody wants to license this for a custom solution where that is not an issue, well, then you can use that full consumer interface to get full access to the web browser and anything else that is Comm-based. Yes?
Does it work in Firefox?
It does. We have a Netscape plugin that hosts the main engine. That is something that's going to be coming out in OTOY 2.0, however. We actually dropped support for Netscape for a while because of, it was getting killed by IE, and then Firefox has sort of emerged again. But we have a Netscape plugin, and we basically need to refresh it for OTOY 2.0. But yeah, it'll run in Firefox. And on the Mac, we currently have OTOY 1.0 content running through the Extra interface, because that is one of the best ways, in fact, that we found to actually get the web browsers on the Mac to run our content. The Extra system on there installs the rest of the engine.
Did I misunderstand you? Does this not work, say, if you're offline but not hooked up to the internet?
No, it can. We actually have many of our games that we've put out there have actually had components that'll work either from an offline double-clickable executable or, for some of our games, if you don't put anything to stop the user from doing this, you can just run them from a local hard drive or file. Some of the services that don't necessarily want that, so yeah, there are tools to limit content so that it doesn't run offline. But for the most part, yeah, we support both. Yes?
What kind of 3D content can be sucked in here? Can it be Maya, XSI?
I'm sorry, can you speak a little bit louder? I can't hear you too well.
What kind of 3D content can be used with this? Maya, XSI?
Maya, Softimage. The art assets, we have direct import for Lightwave because there's actually not very good tools to export Lightwave to any other format. So we can read in multiple UV coordinates from Lightwave. We support .x files directly, and we also are adding support for FBX, which will allow you to bring in stuff from Maya. But a lot of our artists essentially saved out to .x, 3ds, and Lightwave, and those are the best formats to import things in. We also support OBJ directly. I think when we do support FBX, which is one of our things on our to-do list, we'll be able to get in pretty much everything from Maya into the engine. Internally in the engine, we have unlimited number of bones for animation, support for pretty complex materials that probably go even beyond what we're seeing in terms of the material definitions inside of Lightwave, for example. As I said, when you're dealing with things like BRDF materials and even things that are procedurally generated, like the skin shaders that I was showing you, that stuff is just, I don't really see materials even in Max or Lightwave that really sort of correlate to that. So some of the best-looking shaders probably just be written by our developers. But as far as importing just the diffuse maps and geometry and anything else like that, we support pretty much all the major art tools. Any other questions? Yes?
How do you plan to make money from this?
Well, it's a good question. I'm sorry? The question was, how do you plan to make money with this? And the first answer is, well, we already are making money just by doing games for clients, which the list I gave you earlier in the presentation was what we were doing last year, and we're still doing more this year. And that pays the bills. However, it also allows us, we don't have a huge amount of overhead, so it allows us to explore other things. And this free version is not, the way we've been running, let's say, on the free version of OTOY is that for indie clients, we have our control panel, we have our window, which is what we put in there, whether it's an ad that covers the cost of the download or makes us money, is our business. Just as a developer can put whatever they want in their window as well. And this is not something that we see encroaching on the business model we currently have for larger clients that don't, Disney doesn't even want the OTOY logo on their games, so we have to obviously, we sort of separated that out. But our business model, in terms of how we are currently doing it, is the same as it's been for many years, which is we create large web games, and with this technology, usually when I say we, I mean we have a network of developers out there that do it with us and for us, and there occasionally are developers that come to us that want to have their own clients and their own game projects, and we just license them the tool. And so that pretty much sort of covers the gamut of our business models up to this point. Any other questions, comments? Yes?
Do you have any ballpark figures of what it would cost for a custom version of the engine?
The question was, what does it cost for a custom version of the engine? And the truth is that it really costs nothing. We usually bundle that with a project. So the average web game that we do is in the low six figures. It's 100K to 250K depending on the scope of the project. And along with that license to that game, we usually provide a custom version of the engine that suits the client. So those are the only cases that we really have to sort of, as a metric to sort of answer your question with. We've never really had somebody just come up to us and say, well, we want to license the custom version of the engine directly. It's usually in connection with a game project with a budget that essentially covers that license to our satisfaction.
Okay, but I mean, if you make an indie game and you want to make it a commercial game,
yes?
then we need to license it.
Well, it depends. Yes, that is correct. If you're making a commercial game, but you don't mind having it on your own website or on a website that doesn't mind having the OTOY control panel, then you don't need to pay us anything. So that, it's only if you're really the custom plugins or the custom version of the plugin is something that we're finding is necessary for larger commercial sites that don't want that, and that means, you have to come to us and get a custom version of the engine. But if you're just an independent game developer and you don't mind having our little pop-up there, which users might even find useful for being able to see, for example, you can turn off networking traffic, you can rate content. That's pretty much what we're enabling for independent developers, even for full commercial games that are done that way. So if your needs fall within that category, then that license may suffice. Let's see if I can actually show you guys a couple of real-time demos, just very quickly, and then I'll let you come up and see some of this up close. This is OTOY 2.0. It's running in real time, and this is that 200K head I was telling you about earlier. So you can see there's exposure control and lots of different lighting effects in there. But skin is actually one of the hardest things to render, and so we really spend a lot of time on this. It doesn't seem to look that great on this monitor, but I just wanted to at least sort of show you some of these effects running in real time. And again, this is all just running in Shader Model 2. There's absolutely no, we haven't even touched it. It's at Shader Model 3. So this is something that, while it won't run necessarily at tremendous speeds, this is now running at 63 frames a second. On a 4-year-old machine, it'll run probably at a good 15 frames a second and still get this kind of really nice quality. But if you want to see more, I can certainly show you guys. If you want to come up here, I can load up some other demos. Are there any other questions or comments that I can field from the audience in general about presentation? Or yes.
What's your website?
OTOY.com.
Okay.
OTOY.com. And also, if any of you are interested in evaluating the technology, I have some. The OTOY 1.0 SDK is currently available. And we pretty much give it out for free evaluation. So if you want to check it out, come up here, and I'll give you guys a evaluation agreement, and we'll email it to you. Please also remember to fill out the forms the GDC forms about the presentation before you go. Thank you very much.